Okay guys, in the last video we looked at what vector quantities were and what scalar quantities were, and we saw that vectors are basically measurements that have some kind of direction. One of the examples was something called displacement. So basically displacement meant I went from one place and ended up in another. So here's a classic example of displacement. So you can see what I have over here is I've got the displacement symbol. Remember, displacement means change in position. So how does my position change? So what happens in this case is my position ended up 40 meters east of where I started. So what I can do is I can draw a little diagram representing this change in position, this motion. It's called a vector diagram. So here's what you do. You draw a little compass point. That's the first thing you do. So draw my little compass point. There we go, north, east, south, west. I'm going to pick a good scale. Now, I've got this really big number here. It's 40 meters. I got to put that on my page. So we're going to write down 1 centimeter is what we're going to represent a scale version of this. So I'm in the tens, so I'm going to say 1 centimeter equals 10 meters. So just by looking at this, I need to put 40 meters on paper. So if 10 meters is 1 centimeter, 40 meters would be 4 centimeters. So what I then do is I take my ruler, I put it on my paper, and then I draw a line that is 4 centimeters long, exactly 4 centimeters long, from the beginning to the end, including this little arrow tip. So this arrow tip is telling me that I'm going to the east, I'm going because of my compass point, and because the line is 4 centimeters long, it kind of represents, based on my scale, 40 meters east. So this line represents a change in position from where I start over here. So where I start. So this is my start position. And over here, this is my end position. So this line represents this change in motion. I went from here to here. This is 40 meters over to the east. So it's pretty straightforward. So let's just look at the steps that I did here. So first thing I did, I drew a compass. So you draw a compass, and you keep it really simple, right? So think of this. Never eat sour watermelon or something silly like that. Next thing we do, we pick a scale. Make sure the scale you use is convenient. So you can do like something like 1 centimeters on the paper is 1 kilometer in real life. Or 1 centimeter is equal to, I don't know, 10 meters. Or another one is maybe 1 centimeter is equal to 100 kilometers. You get the idea. So basically, to decide on the scale, you look at the original number. So here, it was 40. And if you've got tens, you're going to be using this scale. 1 centimeter equals 10 something. If you've got ones, you use 1 centimeter equals 1. You get the idea. Then you draw your line to scale. So based on the scale, draw your line, the correct length, in the correct direction. All right, so in the correct direction. And then you put an arrow. The arrow tip indicates the vector direction. So in other words, which way I'm going. So in this example, I was going 40 meters east, so I'm going to make sure my arrow tip is on the east side. Okay? So fairly straightforward. Let's look at a couple of other examples here. So if I want to draw, as I said, 40 kilometers east, we've already done that. So first thing I do your little compass point. Never eat sour watermelon. Pick your scale. So I'm in the 10s, so I'm going to use something like 1 centimeter is equal to 10 kilometers. Now, based on this, the line here is 40 divided by 10, or 4 centimeters long. So I draw my 4 centimeter long line. There you go. The arrow tip is going to be part of the 4 centimeters, and it's going to be going to the east. Here's another scale, or another situation. So here, I use my compass point. So first thing I do, never eat sour watermelon. And look at the scale here. I have to use a different one because now I've got ones here. So I'm going to use 1 centimeter is equal to 1 kilometer. So according to the scale, I've got 2.5 kilometers, so my line should be 2.5 centimeters. Be careful though, it's going to the south. So start over here, 2.5 centimeters towards the south. Okay? Now, sometimes I have to label these vectors. So here's an example. So what I'm going to do for vector A, I'm going to put my ruler on here. I'm going to measure the length from here to here. So when I measure it, it's 4.7 centimeters. And according to my scale over here, 1 centimeter is 10 meters. So 10 meters times 4.7 gives me 47 meters. So I'm going to write this down like this. So my displacement, my change in position, I went from here to here, is 47 meters. And the arrow is going this way, according to my compass, is east. So I put east in square brackets. This one over here, B, let's measure it. It's 2.3 centimeters. So according to my scale, 23 meters. So you write this down. My displacement, again, my symbols with the arrow on top, is 23 meters south. So again, this line represents a change in position of 23 meters down towards the south. Okay, when you do this one, third vector, this one is, I believe, 14 meters, so 1.4 centimeters, going to the north. And this one over here is 8.3 or 83 meters, and it's going to the west. So pretty easy. So things you have to keep in mind, have a compass point, have a scale, and then you label or you draw the vector appropriately. Okay, now here's the deal. Real life, I don't have a vector just going east or west or south or north. I'm going to have a vector like this. So this vector is actually not going just one direction. It's going northeast. So here's the deal. Part of this vector is in the north. Part of the vector is in the east. So what we have to do is we have to label these vectors. And we have to take care of angles. I have to measure where we're headed to, because even though this is northeast, check this out. This vector is also northeast, but it's got a bigger angle. How about this vector? Same thing. Still northeast. Look how huge that angle is. So you've got to be careful. Just because you're going northeast doesn't mean you're going the exact same way. So we have to measure this angle. So what we do is we usually measure the angle from one of the compass points. I can measure it here from the north, or I can measure the angle from this side. I could be measuring it from the east. And in the next slide, let's take a look at how we actually do that. So just like before, okay, sorry about that. So just like before, these vectors, when they're at an angle, the size of the vector is determined by the length of the arrow, and the direction is the direction of the arrow. The only thing you have to worry about now is this angle. It's at an angle. So here's what you do. You always have two measurements here. So if I'm going northeast, I'm going to have a north part and an east part. And look how I wrote down my angle. North, 30 degrees east. So what happens is this very first number is where you're measuring from. It's the 0 degrees. That's where the 0 is going to be. And east is going to be where you're measuring to. So the example I have here is I'm measuring from the north, here's my north, 30 degrees over to the east. So north, 30 degrees over to the east. Let's look at this example. In this one, I'm going to be measuring from the south. So I'm measuring from the south, 45 degrees over to the west. Okay, So again, very similar to before. The only difference is we have to measure the angle from a compass point. So here, from the south, 45 over to the west. Here it was north, 30 degrees over to the east. So when you look at both of these, I'm going northeast. And here I'm going southwest. And I'm just basically telling you how much southwest I'm going. So let's look at an angle here. So I can draw the following vectors. The ones at the top are pretty easy. They're straightforward. So for example, here, 35 kilometers east, here's what I do. I put in my little compass point. There we go. Now I'm going to do a scale. I'm going to do like 1 centimeter, because I've got tens, so 30s, right, is equal to 10 kilometers. So according to the scale, my line is going to be 3.5 centimeters. There we go. Exactly to the east. Now I'm not going to worry about the other ones. I'm going to worry about this angled one down here. So move this little protractor out of the way. So here's the deal. I'm going to be measuring this line to the northwest, so somewhere up in this area here. So what I'm going to do is I'm going to pick a spot, and I'm going to make a little cross here. This helps me out. Okay, like this, and like this. Oops, sorry about that. I'm going to go back up here. So just a little cross here. This just helps me when I'm drawing this vector. So I'm going to know I'm going to be going northwest, somewhere over here. Now look at the number. I'm measuring from the north. So I'm going to be measuring from here. That's where I put my 0 of the protractor. So I'm going to get my protractor over here, bring it over here, just like so. And I'm going to rotate it. And I'm going to put the 0 right at the north. Oh, hold on here. Sorry about that, guys. I'll try to rotate this thing. Oops. And I'm going to rotate it. I know I'm going to be measuring the angle from the north. There we go. Let me just move this back. So let's look at it. From the north, I'm going to be measuring the angle over here, 30 degrees. Oops, sorry. Try that one more time. 30 degrees. Oops, that's getting in the way. My north. Hold on here. Why isn't it doing that? Okay, let me try it one more time. 30 degrees over. Oops. Oh, here. Oh, let me just move that out of the way. It's getting in the way. So anyway, what I did is I measured this line 30 degrees over. So it's like this. Okay, let me just do one more time. So here we go. Sorry about that again. So here's the deal. Measuring from the north, 30 degrees over, so I'd be somewhere here to the west. I'm measuring this way, into the west area. Let me move this out of the way. Now, I have to draw a line in that direction. So here's the deal. I need to have some kind of scale. So here my scale is going to be 1 centimeter, so 10 kilometers, right? 10 kilometers or tens. So I'll put my ruler on here, line it up with the 30 degrees. And here's the deal. My line is going to be 1.7 centimeters long. So here we go. There we go. My line is exactly 1.7 centimeters. And I remember I measured 30 degrees from the north over to the west. So let's look at one more example. So this one, I've got an angle, and I'm going to be measuring it southwest. So I'm going to put my little crosshairs over here. They help me out. There we go. And there's my east-west crosshairs. And I'm southwest. So I know I'm going to be going over here. Now, this is my first direction. So I'm measuring from the south. So it's going to be my 0. And I'm going to be measuring over into the west. Let's see how far we have to measure. So I get my protractor, bring it over here. There we go. And remember, I have to measure 40 degrees over. So it's going to be somewhere over here. Okay, there we go. Mark my spot. Remember, 0 is at the south. So move my protractor out of the way. I've marked my spot. And now I'm going to draw my line. It needs the same scale, 1 to 10. So my line's going to be 1.8 centimeters. Here we go. Line it up. There we go, 1.8. So my line's 1.8 centimeters long. My angle's measured over here, 40 degrees. So it's measured from the south, 40 degrees over to the west. Okay, and just one more because this one's a little different. Do the same thing. So what I'm going to do now, I'm going to draw my little crosshairs. Again, this just helps me draw or try to figure out what's going on in terms of direction a little bit easier. So here I'm going to be going southeast, so somewhere over here. And I'm measuring the angle from the east. So this is going to be my 0. And I'm measuring down into this area, into the south over here. So I'm taking my protractor. But look what I have to do now. I have to take my protractor and I have to rotate it. Oops, I'm going to rotate it here. Here we go. So I have to rotate it so the 0 is at the east. There we go. So there's my 0, right? The east off, but you get the idea. And we're measuring my angle 25 degrees down here. So it's right there. Oops, right there. So take off my protractor. And I'm going to draw my line. Now I'm going to use the same scale again. So 1 to 10. So my line should be 2.5 centimeters long. I have to draw this line. So again, 2.5 centimeters. End up over here. And what I did is I have my angle of 25 degrees. So what I did is I measured from the east 25 degrees over to the south. Okay? And that's it for drawing these angled vectors. So you've got a worksheet, try it out. Make sure you're drawing them properly. You're going to have the answers posted online. And remember, the big thing with angled vectors, the first direction here is where you're measuring from, where the 0 of the protractor is. Then the second direction tells you which side you're going. So here I'm from the east, 25 over to the south. So have a little bit of fun.